Hi guys, we're going to have a look at differentiation again today, but more importantly is finding gradients and working out where gradients have a certain value. Now, let's talk about this curve. So I've asked you to look at a quadratic curve, x squared plus 3x. So the best thing you could do now is just pause the video really quickly and think, well, what would that look like? What can I say about it? So hopefully you've been thinking it's a parabola shape, it's a happy quadratic. Hopefully you've set it equal to 0, because when we set the y to be 0, we find the roots, and in doing so you factorized and you get two roots at 1 at 0 and 1 at minus 3. So if you wanted to sketch it, it would look something like that's not too bad, is it? Something like this. The y-intercept, there isn't a plus anything or minus anything, so in theory it's plus 0, so that's why the y-intercept is 0. And you could tell me a bit more if you wanted to, but I'm pretty happy with that. So let's have a look. Right, so here is that quadratic. Now, last lesson we spoke about what we're doing with when we differentiate, we find the gradient function, and I was talking about drawing tangents and looking at the gradients along certain points. So you can see here when it's 0, the gradient is 3, and you can see that gradient changing all the time. As we come closer to the vertex, it gets less steep, so the gradient is smaller. And what's going to happen, do you think, when I get to the vertex? There isn't any gradient. Okay, the gradient is now 0, and then we come on this side, it becomes negative, and the further up we go, the steeper it gets. Okay, so if we go back to our recording, this is a recording, back to our lesson. So for this one, the question would be, let's find the gradient when x equals minus 1. So to do that, the first thing you need to do is find the gradient function, and rather than writing the gradient function, we're differentiating y with respect to x, so we call it dy by dx. So times by the power, reduce the power by 1, and just remember when it's just a linear term, we just keep the coefficient. Right, so when x equals minus 1, dy by dx, the gradient, is equal to 2 lots of minus 1 plus 3, well, that's minus 2 plus 3, and that is 1. So let's go back and have a quick look. We can do that now. So when x is minus 1, the gradient was 1. Okay, you can see that it's just super accurate, super sensitive as well. Right, now there are two ways these questions can be presented to you, and this way people are like, yeah, I'm all over this, super happy with. When you give them this, they start to freak out and they're like, well, why is there a 4 there? What do I have to do with that? But this is at a point when x is 1 and y is 4. But on the gradient function, the only things we can sub in for are x values. So that's all we can do. So sub in 1 into x, so 2 lots of 1 plus 3, and we get 5. Now this has a y value as well, the first question, we just didn't tell you it. So we either do tell you it, or we don't. They're exactly the same. So we're saying when x is 1, it was 5. Let's go back. So when x is 1, okay, can I bring this down? Yeah, I can. So you get 5. Awesome. Right, so let's have a look at a slightly harder one. So this is when people find it a little bit harder. So here we have the same function, same gradient function. Find the coordinate this time when the gradient equals 3. So this is the gradient function that allows us to find the gradient at any point. But if we know the gradient, all we do is simply say, well, the gradient is equal to the gradient function, and then find out the x value. So subtract 3 to both sides, I actually get 0. So I know x is 0. That's not the whole coordinate, so all I have is this part here. So now, what is this value? Well, this is a y value. And over here, I have a formula for finding y values. So the y value is always equal to the x coordinate squared. So the y is going to be 0 squared plus 3 lots of 0. So I'm just subbing x in here for 0. And of course that is 0. So let's just go ahead and check that. Gradient of 3 when x is 0. Now find the coordinate where the gradient equals 0. So again, we set the gradient to be 0. So 0 is equal to the gradient function. We solve. So divide by 2 and we get minus 3 over 2. So we're at this stage here. Now we've got to put in that into the y coordinate. So y is equal to minus 3 over 2 squared plus 3 lots of minus 3 over 2. Not the easiest one. So we've got 9 over 4 minus 9 over 2. I'm just going to change that to 18 over 4. And we get minus 9 over 4. Okay. I just changed that because they're equivalent fractions, and it just made the adding or subtraction process a lot easier. So let's have a look. So we're saying it's minus 9 over 4 and minus 3 over 2. So where has it gone? There it is. So minus 3 over 2, minus 1.5, and 9 quarters is minus 2 and 1 quarter. Bang on. Perfect. Okay. Now, let's have a look at this one. More difficult curve. So, pause it. What does this curve look like? You won't be able to tell me the level of information you could on the quadratics because that's the next stage in your journey in maths if you choose to take it. But what can you tell me? Can you tell me the quadrant where it starts and the shape that it would take? That's the important bit. Right, so if you have thought about it, an x cubed graph normally follows this sort of shape, or it doesn't have to be so bendy, it could be like this. This one, because it's got like cubes and squares and other bits going on, it will take on the more bendy variation, but you should be able to tell me what this is. This is a y-intercept. When x is 0, that's a 0, that's a 0, I get y equals 1. So it's going to have a y-intercept of 1. So what this will look like, it might not be exactly right, but it's pretty much there. It will look something like this, and it will start down in this bottom left quadrant and make its way up to the top right. I'm assuming it's crossing again. It could have come up and not crossed, but it's probably like that. Without any further investigation, I just don't know. I'll tell you what, I've got it done on here. So let's actually look at it. So let's get rid of that one, and that one. There it is. Not bad. That was close. Right, so let's do some questions. Find the gradient. Any mention of gradient, you need the gradient function. So dy by dx times by the power, reduce the power by 1 on every single term. And this on its own, this constant term, that's x to the 0, so times by 0 is going to go. Okay, find the gradient when x is 1. So dy by dx is the gradient function. That's what we're trying to find this time. And we're just going to sub in minus 1 into here. Minus 1 squared is 1, so that's 3. 4 lots of minus 1 is minus 4, so minus 4, we're going to get 7. We'll check it at the same time as this one. So exactly the same thing as before. So dy by dx, this time we're putting in a 1, definitely easier than a minus 1. 1 squared, 1, 3 of those is 3, take away 4, and we get minus 1. So, well, I think you can take my word for it, but let's just do it anyway. So what did we say? At minus 1, the gradient was 7, and at 1, the gradient was minus 1. 7 and minus 1. Beautiful. Okay, let's just have a look at this one because it's going to be a little bit more complex than the last variation. So the gradient is now equal to 3. So the gradient is equal to 3x squared minus 4x. So now it's a quadratic. It's not as simple as the linear version. So when it's quadratic, you don't get x's on one side, numbers on the other, you get everything on one side. But you've done so many solving quadratics now, you should be pretty good. Ugh. Are there factors of 9 that make 4? No. So this one, I should have thought about this question a little bit better, but you need the quadratic formula, which, do I have my... No. Right, so we're just going to have a look at this one. Where is it? There. So when the gradient is 3, so if we take this round, so it will happen at 2 points. It will actually happen somewhere around here, and you can see that this isn't a nice number, that's why it doesn't factorize. Okay, but it would also happen over here again. Okay, and you see those points there were at level, so when you solve this, you're going to get 2. You might get 1, you might just get 1 repeated root, but quite often you will get 2 answers because of the shape of the graph. Let's see if this one works. So 0 equals 3x squared minus 4x. Yeah, we can definitely factorize this one because it's just a single bracket. So 3x minus 4. So we know this is going to happen when x is 0 and when x is 4/3. Yeah, just set that bracket equal to 0 if you're wondering how I did that so quickly. So let's go to x is 0 and x to be 4/3, 1 1/3, and you should believe me that it works. So when x is 0, we had a gradient of 0, and when x is 1 1/3, you can see that's just about... You can't quite see this coordinate, but over here where I'm pointing it says 1.34, so it's pretty much spot on. Okay, so that's it. Best of luck, get on with your questions, and then tomorrow, if this goes well, we've got a Quizlet Live, it's going to be loads of fun.